Okay, so we talked about experimental probability last lesson. We know that the probability of an event is the number of occurrences of the event over the total number of possible outcomes. So let's look at this example. A bag of candy has 15 red items, 10 green candies, 12 purple, 13 orange. If you add that up, it turns out there are 50 pieces in total, 50 pieces of candy. Okay, so we're supposed to calculate the probability of randomly choosing a red candy. So picture reaching into a bag without seeing it. What is the chances that the red candy comes out? Well, red, there are 15. So if there are 15 favorable outcomes, that's what we're looking for, 15 ways you can pick a red out of 50. This is the probability. Now that's a fine answer, but if you use a calculator and you went 15 divided by 50, you're going to get decimal 3. If you want to change that to a percent, you're going to multiply by 100. This is 30%. These answers are all the same thing. Okay, I don't care which way you answer it. Okay, so that's the first part. Now we're supposed to do the green candy. What is the probability? Let's put G in here. The probability of green. Okay, there are 10 green out of 50. So if you wanted to put that in the calculator, this is going to be 0.2 or 20%. All right, and we'll try one more. What is the probability of purple? Well, there are 12 purple out of 50, so this is 0.24 or 24%. So that's the probability of each individual type of candy. What if I read that differently, though? What if I read it, let's read it again. Calculate the probability of randomly choosing a red, green, or purple candy. In other words, what if I thought all three of those was okay? In other words, probability of red, green, or purple. I would take any of those outcomes. Well, we know there are 15 red, there are 10 green, and there are 12 purple. If I add that up, there are 37 what we would call occurrences out of 50 possible. Okay, and if I put that in the calculator, 37 divided by 50, it will give me 0.74, and if I multiply by 100, I get 74%. Okay, now if that ever came up in a test and you weren't sure which way the question was being asked, you should ask that, because I'm not trying to trick you. I just want you to see that there are two different ways of that question being answered. Okay? So let's try this next question. It says, determine the probability of drawing a spade from a deck of well-shuffled playing cards. Okay, so what we have here is a picture of all of the cards in a deck. If you're not familiar with a deck of cards, there are 52 cards in a deck. Okay, you'll see there are 13 of each. There are 13 diamonds, there are 13 hearts, there are 13 spades, and there are 13 clubs. Okay, now if this was ever a situation where you didn't understand this and you didn't know what was being asked of you, you should never lose marks because you don't know what kind of cards are in a deck. So you should know that you can ask that. Okay, but here they are. This is a deck of cards, 52 cards. So the question says, what is the probability of drawing a spade? So let's write that. The probability of a spade is going to be the number of favorable, or the number of spades, there are 13 of them, out of the number of total possible. There are 52 cards. Okay? It says to state it as a fraction. By the way, you could reduce that. It's 1 out of 4. Okay, so let's just write fraction. Now if we wanted to do a decimal, you just use your calculator for this. You're going to take 13 divided by 52. Okay, and it should give you 0.25. And then as a percent, okay, if I want percent, I'm going to take that decimal and multiply it by 100. Okay, 25%. And then in words, well, what's the probability of spades? It's 13 out of 42, out of 52 cards. Okay, so that's probability, sort of just the intro to it. I'd like you to try this assignment 1. Okay, there's a few questions for you to do there. All right, and then I'm going to continue with the next lesson. Okay, but please pause the video right now and go do that lesson, that assignment 1. But we're going to move on to this next lesson, because I don't think we need to start a new video for that. Okay, so let's fill in some blanks here. First of all, what goes in here? We can use probability to predict answers to questions. If our samples are random, and another word for random is fairly chosen, in other words, chosen fairly, we can use these probabilities to make predictions. Okay, we use probabilities to make predictions in many areas of our lives. Let's look at a conversation here. Maybe not realistic, but you'll get the idea. So Dean says, I'm going to be in trouble in math class today. Kara says, why? Dean says, I didn't do my homework. Kara says, so what? I didn't either. Dean says, since the teacher asks half the class for answers each day, he'll probably call on me today. And then Kara says, he called on me yesterday, so he probably won't catch me today. All right, let's look at that conversation. Okay, in this dialogue, each student is making a judgment based on probability. Who is correct? That's the interesting one. Who's correct here? Is Dean correct? Dean says that because the teacher asks half the class, he'll probably call on me today. Well, we know exactly what the probability is. The probability of being called, if it's half, is 1 out of 2. Okay? So when he says he's probably going to be in trouble, well, it's 50-50. He's got a 1 in 2 chance of being in trouble. Okay? Then let's look at what Kara says. Kara says, he called on me yesterday. He probably won't catch me today. Well, what's the probability of Kara being asked or called on? Guess what? It's still 1 out of 2. Okay? It doesn't matter if they were called on yesterday. If they're going to be called on half the class, you have a 1 in 2 chance of being called. It's that simple. Okay? So, who's correct? Well, Dean's probably more correct than Kara is in this case. But when they're both saying, I'm going to be called or I won't be called, they're both 50-50. So really, they're both kind of, they got a 50% chance of being right. Okay, let's try the next one. If you are selling ice cream cones, and you know that the probability of someone asking for vanilla is 3 in 4, then you can use this information to order enough vanilla ice cream to serve your customers. Okay, so that's an example of using probability. If I know that every 4 people come in, 3 order vanilla, then I know that I'm going to have a lot more vanilla than other flavors. Next one, if the weather forecast calls for an 80% chance of rain, would you take your raincoat? Well, I would say yes. 80% chance of rain. This is a pretty good chance of rain. Okay? That means it's only 20% not to rain. So it's more than likely that it will rain. So I think you would take your raincoat there. Okay, let's try some examples now. If there is a probability that 1 person in 7 has green eyes, how many in a group of 100 or 210 are likely to have green eyes? Okay, well, we should set up a proportion here. Let's compare green eyes to all eyes. Okay, we know that there is a probability of 1 in 7. So 1 out of 7 has green eyes. 1 green eyes compared to all eyes is 7. Okay, and then we're told that there are 210 total people. So let's set this up as a ratio. Would the 210 go on the bottom or would it go on the top? Well, what is 210? Is 210 the number of green eyes or the number of people? It says that there are 210 people, so they're going to be down here. So this is what we want to find out. This is what we call a proportion, and we can solve this by cross multiplying. So I'm going to go 7x equals 1 times 210 is 210. And then to get x by itself, remember this is 7 times x, so I'm going to divide both sides by 7. And x is 30. So out of 210 people, you would expect 30 people to have green eyes. Okay, so that's how we use probability to predict. Let's try another one. I'd like you to pause the video here and see if you can do this question. Okay, it says in a pack of 20 wolves, 9 had frost damage to their ears, 11 did not. If there are an estimated 610 wolves in Yukon, how many do you predict will have frost damage ears? So here's our ratio. Frost damage out of total wolves. Okay, and it gives us that 9 out of 20 had frost damage. Okay, and then we want to compare that to the total number of wolves. There's 610 wolves. We want to know how many would you expect to have frost damage. So here again is our proportion. Okay, so cross multiply. 20x equals 9 times 610. That's going to be, I think that's the number. Okay, just grab my calculator, make sure. 9 times 610 is 5,490. Good thing I checked. Okay, and then if I want to get x by itself, I'm going to divide both sides by 20, because it's the opposite of multiplying by 20, and I get x is 274.5. Wolves will have frost damage, but you can't say 0.5 of a wolf, so we're going to say approximately 275 wolves have frostbitten or frost damaged ears. Okay. All right, try the next one. Again, pause the video, do it on your own, and then see if you're correct by checking the answer. Okay, it says if you enter a store promising to award 10 door prizes per day, it is near closing time and they have awarded 6 gifts so far. If there are 200 people in the store, what is the probability of you receiving a door prize? Okay, if 6 prizes have already been awarded, then there are 4 prizes remaining for the customers. Okay, so the probability of receiving a door prize is what? Well, you've given 6 gifts already. There are 10 total door prizes, so there must be 4 remaining. Right? And if there are 4 remaining with 200 people in the store, that means you have a 4 in 200 chance of getting the gift. Okay, and we can reduce this to 1 over 50, or 0.02, or 2%. Okay, you have a 2% chance of receiving a door prize. Okay. Let's do this next one. Okay. So I'd like you again to pause and then try this. So it gives us the information on a graph, and it says determine the probability that a student chosen at random from these classes, A, uses the internet for 12 to 16 hours a month. Okay, well, if you look at the internet usage by students, that's what this graph is saying. We have this many people use it 12 to 16 hours a month. Okay, and if you look at 12 hours, that there are 8 people that do that, and there are 10 people that use it 16 hours a month. So we're going to go 8 plus 10. This is 18. So we have 18 out of, well, how many are there in total? Well, we need to add up all of these numbers. Sorry, that's how many hours. We need to add up. It would be 4 plus 6 plus 8 plus 10 plus 16. Okay, this one is 12 plus 10 plus 8 plus 4 plus 2. And that turns out to be 80 people, or 80, I guess we should say students. Okay, so again, what did I do there? I looked at the top of each of these lines and said, well, how many students does that represent? Okay, so it's 18 out of 80 that use it 12 to 16 hours a month. We can reduce this. This is 9 out of 40. Okay, let's try this next question then. Use the internet for 16 to 28 hours a month. Okay, so we're going to use this column, this one, this one, this one, and this one. If I add up all of those numbers, that's 8 plus 10 plus 16 plus 12 plus 10. This is 48 students use that much internet. And so it's 48 out of 80. Okay, the probability, now we could say probability of 16 to 28 is 48 out of 80. Okay, let's try to reduce that. How can I reduce that? Well, you know what? If you get stuck on reducing it, don't stress about it. Let's go put it as a decimal. Okay, instead of 48 divided by 80, this is 0.6, which is 60%. So 60% of the students use it that much per month. Okay. C uses the internet more than 4 hours a month. Okay, well, here's 4 hours a month. Everybody else is more than 4 hours a month. So what is the probability of more than 4 hours per month? Well, we know there's 80 total. How many of them use more than 4 hours? Well, there's 4. Okay, this first bar represents 4 use it 4 hours. That means the other 76 use it more than 4 hours. Okay, and if you put that in the calculator, I think that gives you 0.95 or 95%. Okay. D, will the probabilities determined from these 3 classes hold true for grade 12 students in Manitoba? Explain. Well, it's really hard to tell, but this sample size is not really large enough. We've only asked 80 people. I don't know if we could use that to generalize throughout all of Manitoba. It really depends on where these students are, too. We know that some students in remote areas of the province don't use as much internet because they don't have as much access to it. You're also going to have some students who work a lot, so they're not going to have a chance to use internet as much because they're doing other things. Okay, so I'm thinking this is maybe here's a term for you. I don't know if you know what this means. The sample size is not big enough. I don't think they've asked enough people. That's what sample size is. It's the number of people that were included in this sample. Okay, and we'll use this may not be representative of the population. So this data might not represent every single student in the province. All right, that's a bit of a longer lesson. Let's like you to do assignment 2 now. Please have that done for next class.